Okay, so a couple more things to go through before we get into um, the detail of how people have used FrameNet to do some of this stuff. First of all, um, just one quick overview of word statistics. Um, they are correlations that give you implicit semantics, right? So just like, the statistics of, just like your brain is implicit semantics as far as the computer is concerned, the way that you take the way that words are put together, they can reveal something about what the meaning is. So just to make that clearer, if you consider a sentence like, a herd of gnus jumped over the fence, then even if we don't know what a gnu is, we learn something about them just by seeing that it occurs in a close context with herd, right? So there's only certain things that can occur in herds. So you would guess that probably it's a hoofed animal, something like that, and you'd be right about that. And so that can be figured out, just that correlation can be figured out without knowing anything about syntax, right? It's, in order to get good information out of this, you need to have a lot of repetitions, right? Because let's imagine that, I was just looking at the statistics of this sentence. Well, it happens that actually there aren't any repeated words in this sentence, right? So I can't get any frequency information from something this short, that tells me that herd is an important word that tells me something about a GNU, right? I mean, as far as the computer's concerned, could be the important word that tells me about GNU. If it doesn't know anything at all of the words are equally meaningful, as in they're all equally meaningless. But if you use statistical techniques, you can figure out, for one thing, that is amazingly common. That it's found in every genre of English, that it's found in every kind of topic about English. And so you can figure, just based on statistics, that that's not going to be a very informative word. Whereas you'll see that GNU is actually the one word in the sentence that really is not going to occur in very many contexts. You'll see that it's associated with herds or other things like that. If you look at other things that occur in the context of herd or jump, it's a limited set, right? The things that will consistently occur in those contexts. And so this is actually what gives you the technique of latent semantic analysis. So it's implicit semantics, figuring out that GNUs are something like cows because cows are associated with herds, and figuring out that GNUs are something like horses because they're associated with herds and they jump. I assure you, cows don't jump very much. So you can figure out that a GNU is more like a horse than it is like a cow, and it's also more like either one of those than it is like a person. Okay, so this is the sort of completely statistical method. I just want to point that out because this is just to say that there are kinds of non-structured semantics that are sometimes useful, and if you're ever trying to convince somebody to use FrameNet data, this is your competition, effectively. Now, of course, the reason why you can't use this for a lot of the things we were talking about is because this doesn't tell you how what the category structure is. This doesn't tell you how GNU relates to herd, like what is the meaning of that relationship. It doesn't tell you anything about that. So, in fact, all of the relationships are equal because all the relationships are just correlation and strength of correlation. Okay, so this will be useful for plagiarism detection, for sure. This will be really useful for detecting topic clusters. So sorting things into the same topic, it's good for that. But this is not going to tell you who's a good president, who's a bad president, and things like that. Okay. I need to give you one more concept before we talk about systems, because since natural language processing is engineering, they need a measure for success. I mean, if I were doing mechanical engineering, an obvious measure would be rate of failure, right? How frequently does this machine break down? And even when it doesn't break down, how often does it do the right thing? You know, how well does it perform? Does it do the job exactly the way you want? And how often does it break down? Those are, you know, for all the stuff that we use in our lives, those are two really important questions. And natural language processing is no exception, right? They also have to measure those things in order to be able to improve them. It's an engineering project. So one of the measures they traditionally use is precision. So that basically says, okay, I'm going to look at all the answers that your system gave me. So you wrote a system, and it's supposed to do something. And now I'm going to look at all of the answers that it gives, and then I'm going to say, how many are wrong? Right? So there's going to be a percentage. Some percentage are right, some percentage are wrong. Precision is a measure of exactly that. Okay? Then recall is when, let's say I know what all the right answers are. I'm giving you a test. I know what all the right answers are, and you only gave me half of them. So this is sort of like, you know, when the technique breaks down, right? The machine doesn't do what you need it to do. And this is recall, penalizing for right answers that are missed. Okay? Now, just to talk about this for just a moment, you can see that these two things have different importance in different tasks. So these are also used when I'm trying to identify, you know, in the intelligence community, like when the CIA is doing something. And let's say what they're trying to do is limit access to some site, using voice recognition to do this, right? You can apply these same concepts, right? You want something that really, really, really has amazing precision. You don't want it to let anybody into that place that's not the right person. Now, if it sometimes misses the right person, that's okay. They say the passphrase again, then maybe 2 or 3 times. But that's not so bad, right? You don't want them to get into the super secret place. So for that kind of job, you want super high precision. But now let's look at the other case, basically the Google case. So let's say that we have somebody who's looking for some information. And you know that the information is out there, but you also know it's probably pretty hard to find. So what you do is you give them a whole bunch of stuff. Some of it's going to be wrong. Some of it's going to be totally irrelevant. But because the person is looking at it, and you know they're just going to use whatever information they get this way, it's totally okay to have bad precision. But you really need to have good recall. Right? If the right answer doesn't appear in the set of choices that you give to the person, it, you know, doesn't help at all. It doesn't do the job. Okay? So 2 different use cases for needing to optimize these 2 things. So whenever people are making systems, they're always producing some kind of parameter that lets them tune between these 2 things. And you should keep in mind that for the different tasks, people have different ways that they've optimized that. And especially if you read any papers about this stuff, this is most of what, at least to me as a linguist, it seems like this is all they talk about, is precision and recall. And there are really good reasons for that, but it is amazingly boring for somebody who's trying to do semantics. Okay, so how does FrameNet help? How does FrameNet actually let you do any of this natural language processing stuff? Before we get started on that, I'm just going to make an aside. FrameNet was not originally designed to help natural language processing at all. The original FrameNet 1 project, which was started by Sue Atkins, a dictionary maker, and a researcher of dictionaries, and Chuck Fillmore, who, of course, as you all know, cognitive linguist, studies the structure of frames, all these things. Neither one of those people was a computer-y people, right? They knew that they needed computers in order to be able to do this, but what they hoped to be able to do is to provide a resource that let language learners really understand how English works in a way that they couldn't understand from just reading a normal dictionary or looking at a normal dictionary. So originally, FrameNet was designed for you guys learning English. That was the original idea. However, after the first 3-year project was done, and we were trying to get funding for a second round, it became really obvious that since we were applying for funding from computer science, that what those guys were going to want to see was real engineering stuff. And so we saw that it really was useful for that and applied, and that's how FrameNet 2 came about. So FrameNet 2 was much more designed from the beginning to be friendly to computational processing. But you should keep in mind that because we didn't start there, we have continually had a lot of problems getting these things to be taken up by the computational community. So we're getting there. A tiny little bit of preliminary about what we actually use ourselves as far as natural language processing in FrameNet goes. We have part-of-speech labels automatically applied. So we are using some natural language processing to do that. There's the British National Corpus, part-of-speech tags, and then we automatically apply Penn tree bank tags. So you remember those tree banks I was talking about before? Well, the one thing that we do use out of the tree bank projects is the part-of-speech information. So they annotated a lot of stuff for part-of-speech, and now they have trained systems that can automatically apply that part-of-speech. If you need the details on this stuff, it's all very much available, but I'm not going to go into the details of what our part-of-speech system is. That obviously will be different for every language. And the same thing goes for syntax. So in FrameNet, for the purposes of finding good example sentences, we actually automatically parse the sentences as well, because we want to know whether this use of the word forge has a direct object or not. Right? That's going to make a big difference for whether this sentence involving forge should go in a motion frame, like forging ahead, striding forward, or into a frame about creation, like forging a chain or forging a sword. So those are really different, and it's very useful for us to be able to sort them in a heuristic way using the syntactic parsing. But inside FrameNet, in order to, at least our principle was in order to make it easier for people to use FrameNet for automatic processing, we apply our own phrase types. Now, the phrase types that we use, they're just our own set. A set, I mean, you know, Chuck Fillmore is the head of the project. He should know something about syntax. It makes sense that we didn't want anybody else's syntax because we knew how to do it. However, what this means is that all of those automatic syntactic systems that automatically parse, well, none of those is using our set of syntactic tags. They're using the syntactic tags of the Penn tree bank corpus. It's obvious, but it does mean that there's a mismatch. So that means that in terms of natural language processing, the first step for everybody who has ever used FrameNet data for any purpose is to drop the phrase type and grammatical function information that we spend time annotating for us at FrameNet. And I actually have some stuff to say about that towards the end of class today. So now I'm just going to go through a list of different projects that have used the FrameNet information and how they used it, what they got out of it. There's Narayan and Mohit, 2003. They were doing an information extraction task where they were looking at newspaper articles about what happened with a particular crime. So they're following a particular person who first is accused of a crime and or arrested, and then they go through a trial, and then perhaps after the trial they end up appealing. And you want to be able to connect that together, even though that information is going to be found in many different newspaper articles over time. Right, so if I want to fill out the full history of what happened to somebody, I'm going to need to look at a lot of articles. Well, what they showed was that if you try to use very simple information extraction techniques, they don't work very well for this. In part because the first stage for information extraction is to find the text that you're then going to get all your information from. Right, so again, imagine I have this huge corpus of newspaper text. It's sitting around, and I'm supposed to find what happened to Jane Stevenson. So Jane Stevenson has some relation to a crime, I know that. So my first technique is to find the documents that mention a Jane Stevenson. And if I expect to have everything filled out from one document, I'm kind of in trouble for this type of question. So one thing that they were able to do is show how to have a bunch of separate information extraction modules and then tie the information together using FrameNet. So the way that that worked was that they basically used the reasoning aspects of FrameNet, because the person on trial is the same as the person who's accused. There's a frame element to frame element mapping in the FrameNet relations. And so they were able to use that information, and what they did is they didn't increase precision at all, but they did increase the number of true facts that they found. They increased the amount of what they were looking for that they got. Their accuracy on whatever they got was exactly the same as before, but now they have more. Okay? For most other techniques that are going to use FrameNet, you need some form of semantic parsing. And generally speaking, it needs to be automatic semantic parsing, right? If I want a completely automated system that just does some job for me, it has to first, figure out what are the semantic labels to apply to the sentence so that I can turn that into a model or use it heuristically or whatever it is I'm doing to do translation, to do search, whatever it is I need to do this part first. Now, the way that this has been done is that people take as their input the semantically parsed FrameNet corpus, right? So as I was saying before, how is it that I automatically do stuff? Well, what I do is I take some training examples that annotate what it is I'm looking for, and I figure out how that correlates with stuff I can already do, right? So the way that people have done this is they use the syntactic and word statistics in order to first identify the frame, and then they use those same statistics in order to identify frame elements. And typically, especially for frame elements, it's the syntactic stuff that's really important, but this sort of implies that you've already solved the syntax problem, right? So the whole idea is that you use something you already have, a syntax parser, and then you use it to get statistics on how its output correlates with the thing you're actually aiming for, semantic parsing. Usually they only do frame elements because that's the most obvious part that you want for all of these other semantic jobs. You need the frame and you need the frame elements. But there are some systems that are starting to annotate some other things, and there's good reasons to do that. There are actually a number of ongoing contests where people actually try to do this and compete against each other to see how well they do. The main example, certainly the only example for FrameNet, is the SEM eval competition, which grew originally out of the sense eval competition, where people were trying to do word sense disambiguation. So that's an old task that's been around for a while, but you can see that in order to automatically do FrameNet annotation, the first stage is basically exactly the same as word sense disambiguation, right? So it makes sense that we went into that contest. Every year that we do this, we have a small number of participants, very small, 3 or 4 teams, which is less than almost any other competition that I know of. One of the reasons for that is because people always do terribly, basically. Compared to any other competition they could involve themselves in, this one is really, really tough. And so there aren't that many teams that think, I want to do all the work that it requires for having a syntactic system, and then also build a semantic system on top of that, and then have it not do very well. And there's enough, this has been going for enough years that people know that that's what will happen, and so it's not very encouraging. It turns out that programmers are people too. So the results do improve every time, but we also make the task harder. So in the very first time, we actually provided them with the frame and then asked them to do the frame element annotation. And that was pretty tough. The next time we had them, we had the frame be open, so they had to find the frame and the target. And then they also had to find the frame elements. And then the next time, we said, okay, we're going to annotate some stuff in frames that we don't even have in the training data. So your target annotation will include things that you have never seen before. That's really tough to figure out how to do, but actually some people did do that, where they figured out a system using WordNet, using a bunch of other resources, using correlation statistics that would suggest new targets to frames that we already have, or suggest nearby frames that would work. So then after that, we had a competition in which we also wanted people to figure out the fillers of frame elements that were not local. So this is actually not something that we do in FrameNet usually, but we did give them an annotated corpus for that. So normally, if I say something like, I already did, so I already did implies I already did something, but it's not there in the sentence. Well, with this particular task, we actually annotated the chunk of a previous sentence that indicated what was the filler of that frame element. And people did that. And it was hard to do, but some people did something. So here's some systems. Shalmaneser, which is actually an abbreviation for shallow semantic parser, which is the weirdest name I've ever seen, it's the first major release system that was just a tool that you could take home, install on your computer, and have it give you automatic semantic roles. It wasn't fabulous, but it was primarily designed to be something you could actually install. So there's always this trade-off with engineering. Do I make something that's easy to use or really good? This one is in the easy to use category. Then there was a system from Lund. Lund is a system that actually can identify the nearest frame for some target that it has not seen. So if it looks at a text, it figures out what probably ought to be targets, as I was going through in the full text annotation with you guys before. Well, this system does the same thing. It says, well, this word should be a target in FrameNet, and then it looks in the FrameNet data and it says, I don't find a target for that one. And it says, but probably it can belong to this frame that I have, or it should be near that frame. So it's pretty impressive. More recently, people have started annotating all the layers, including things like the support verbs, and also getting null instantiation information, and all these other things that are actually pretty important for the downstream tasks, but that were neglected in the earlier versions. All right, so another task that has been done is question answering. So Steve Sinha's thesis was designed to answer questions about weapons of mass destruction. This was really topical at the time. This was just after the US had foolishly invaded Iraq on the supposed basis that there were weapons of mass destruction there. And then afterwards, we find out that the people who had tried to figure out this information had never properly tested their hypotheses. So this provides potentially a sort of objective way to test hypotheses. So you have texts which represent information about weapons of mass destruction somewhere. You do some form of automatic annotation of them. Perhaps in this case, you might even do hand labeling, right? If the whole point of this process is to be objective, it might be worth it for you to hand annotate some of your information so that you can make it definitive, right? The annotation is decided on a completely independent criteria from intelligence priorities or political bias or any of these things. And so even though it could be biased or wrong in some way, it's probably not going to be biased or wrong in a specifically political kind of way. In this technique, he actually used simulation, which was based only in part on our frame relations. most of what he used FrameNet for was the automatic semantic role labeling versus hand labeling, which he then used as an input into his system that would answer questions like, is Kuwait likely to develop weapons of mass destruction? And here you have a set of texts. They see things about what weapons Kuwait has now and what preconditions they have met. So do they have the scientists? Do they have the money? Do they have the manufacturing? Right? I mean, these are preconditions that go into a weapons of mass destruction program. And he could hook up those components with FrameNet frames. So FrameNet has a frame about science. It has a frame about research. It has a frame about manufacturing. And so he could look at those frames and use those as input into his reasoning system that was much more complete than you could get just from using FrameNet alone, because we don't have a model of weapons of mass destruction in FrameNet. Okay? Basically, in terms of results, he showed that it could answer some questions. It's a very, very minimal result, and I actually haven't seen people follow up on this very much. One set of people who are interested in following up on this, although they are doing sort of a more basic task in order to prepare for that, is reasoning. They have formally ontologized FrameNet relations and all the other FrameNet information on things like, if there's a frame element, a core frame element in a frame, and it's not in an exclusion relationship with some other frame element, then that means whenever you have the frame, you can conclude that some filler of the frame element is present. Amazingly low-level conclusion to know that, for example, in the giving frame, whenever I mention giving, that there has to be something which is given. It's really, really low level, but you know, it's still better than not knowing that. And that's basically what they've done. They do show that you can get a large number of solutions, what you can call axioms. By looking at the FrameNet data in this way, you can transform it into a sort of axiomatic technique. Another task which has shown some success is text tiling. So text tiling is when you want to figure out how to divide between some text that has a bunch of different topics in it. And you want to say, aha, here's where the topic shift happened. So, for example, if you were doing automatic text tiling on my lecture today, you would want to know when I switched slides. You would want to know when I switched major sections of the discussion, right? And there's a very definite community that is dedicated to having a competition about dividing up news broadcasts for each news segment. So that's a very defined task. It's also nice because you can get a kind of limited but useful access to news broadcasts, and generally they're okay with you doing research on that stuff. Whereas if you tried to get the deliberations of a jury or a trial and tried to do this kind of task, you know, other things that might be really important, you can't do it just because you don't have access to that information because it's protected in order to protect the participants. So this is a nice context for people to work on this problem. And Rebecca Green used FrameNet and a whole bunch of other things, including Longman's dictionary and thesauruses, in order to cluster words into virtual frames. She actually generated sets of words they were intended to represent a cluster of words that could be one frame, even though we hadn't done it in FrameNet. So there was a lot of, the quality was extremely variable. Sometimes I would look at a group of words that were produced from this technique and go, yeah, we should make that frame. I would know exactly what the frame was, it was obvious, and it was clear that this was at least a good initial clustering, right? As always, if we made that frame, we would look at it and probably decide that one of the words didn't belong, and that we should probably add a couple others, things like this, but it would be as good as I would produce as an initial pass. However, there were other frames that were not identifiably different in any way that I could figure out, that were terrible. That just had no identifiable center, that really did not pick out a concept that I would ever want to turn into a frame. But it's the only technique that really, really, really I can think of that just definitively showed that FrameNet actually helps. So when she did all this stuff, she actually showed several percent improvement. And that doesn't sound like a lot, but it's actually pretty good for figuring out where the boundaries are between one news segment and the next one. So it's an interesting result from that point of view. Okay, now we're getting to stuff that is a little bit more speculative, but I have done some work on this. So as I mentioned before, automatic speech recognition is what you should call a non-semantic part of natural language processing, right? All I don't care what the guy means, I just want to know what he said. So for example, transcribing a trial, or transcribing a meeting, things like this, you just want to get the words down exactly. Well, turns out that's pretty difficult. And as I mentioned before, it's not solved if you change any of the conditions. So if you change the speaker, it gets worse. If you change the room, it gets worse. If you change the microphone, it gets worse. If you change the topic, it gets worse. And if you change multiple of those things, then it might not be useful at all. So one bit of collaboration that I did with somebody who actually is in the automatic speech recognition field was to try to improve some of that brittleness. So the technique fails if you change anything, maybe we can make it a little bit more general. So one idea we had was to take a corpus that's going to be used for automatic speech recognition, and then we would use FrameNet to actually paraphrase that entire corpus. And then we retrain the word statistics that are the basis for figuring out what somebody said. So a large part of the automatic speech recognition system is the statistics of what word comes after another. And while from one viewpoint, that is implicitly semantic and syntactic, right? Because it's our semantics that drives our syntax that causes us to produce the word sequences that we produce. But you can flip that around. You can also say that semantics is implicit word sequence. And that's basically what we did with this. And while we didn't get very far, because we were actually funded only for a short amount of time, we did show that you can at least improve the language model. So you can make the language model of the text a little bit more general in the right kind of way. We never hooked this up to an actual automatic speech recognition system because we couldn't figure out the right way to do that that would be scientifically meaningful. So more of what's next. One thing that you could use FrameNet data to do is to actually improve these parser results. So, as I mentioned before, almost everybody uses a pen tree bank. And the pen tree bank is terrible in several different ways. It is big, and it's hand annotated, which is what you need. And all of that is very nice. But the genres are so narrow that it really limits your ability to annotate anything that's not a newspaper. So one thing you could do is you could actually take all of that FrameNet syntax that everybody throws away as their first step, and you could actually use that to train a syntactic parser. This is an idea that I only had relatively recently, at least in terms of actually applying for funding. So I'm going to apply for funding to do this project, but it's only in the dream stage. So there's no results to report or anything like that, but reasons why I think it's a good idea are the fact that just like all the other cases where we saw that if the training data and the testing data are mismatched, that it hurts our results, right? So if I'm training on Americans speaking American English and I switch to British people speaking British English, I'm not going to do very well. Well, the style of syntactic annotation is actually the same. And because all of the semantic annotation in FrameNet actually assumes a FrameNet kind of syntax, you're actually getting some degree of error introduced by the fact that you're automatically annotating with a totally different syntactic system. A system that has, traces and movement and all sorts of strange constituency decisions that we don't agree with. So because of that, it makes it harder to match these syntactic parses to what we actually do. So I would at least hypothesize that if you trained a syntactic parser on FrameNet data, it would actually help you to do semantic parsing of FrameNet data. This isn't as crazy as it sounds because we really have quite a lot of data in FrameNet. I checked it out, and we have a number of sentences which is actually quite comparable to the number of sentences which are used in the pen tree bank. I was surprised to realize that we had done that much annotation. But we have. So it might actually really work. So stay tuned about that. Okay, so I'm just going to mention this additional reading. It didn't fit on the other slide, so here it is. The name is terrible, but these slides will be uploaded to the website, so you'll be able to get that. I'll also include some additional readings for the other things I talked about. I don't have anything else to talk about today, but I wanted you guys to tell me for a couple of minutes whether this was comprehensible, because I'm still laboring a bit to try to figure out what is understandable and what isn't understandable to you guys. So I'm not going to ask, did you understand? Because you will all say yes or you won't say anything. What I'm going to ask instead is whether is any of this interesting enough that you're going to go and read any of these papers. Now, obviously, it's not interesting enough if I haven't explained it well enough. But I would really like to know. So I'm going to ask for some volunteers to say.
Não.
Well, not that I didn't understand, but I'm still digesting all the information.
Muitas coisas que eu ainda não tinha
So many things I didn't heard before.
Então, são muitas novidades.
So it's too much new stuff at once. And what I think it's interesting was about the tools that use the FrameNet information. And I believe that I have a few doubts and I will read about it. But so far, it's okay.
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 Well, there's a lot of new information to think about it. But I found interesting the way that the computer, they're making projects with the computer to analyze semantically the sentences. This is very new and will help very much to find things on the web. I found this is a very interesting feature.
Okay.
Bom dia.
Good morning.
Na verdade, a primeira
Actually,
parte
the first part about the techniques, holistic and statistical, for me it was clear the way they both are used, one complement the other, and it's impossible to use them in distinctive ways, but in the second part, when we look inside the semantic and syntactic aspects and the use of how those analyses are done, it's a little bit complex, but I believe that it's going to be clarified as we go on and with the readings and with the next lectures too.
Thanks.
I think that my main point on that and the thing I want to study more about is how to train computers, in fact, to use the FrameNet database. And that's why I asked you in the beginning on the specification of genres or the type of information you want to have semantically parsed. That's the main idea. I do think that we could start, at least for FrameNet Brazil, to try, and I think the correct verb is try, in fact, to develop some applications, some small applications to solve specific problems. So, for example, I do have an idea, but it's just an idea, that was born together with the preparation part of this international school, when I discovered that I couldn't find anywhere in this university a website that told me how many auditoriums do we have, if they are or not prepared for automatic translation, if they have multimedia projectors, and how many people. So I think, on the other side, that we do have plenty of texts in the university websites, be it in the news section, when, for example, I say the College of Liberal Arts is holding the International School on Frame Semantics. It's going to be held at the auditorium, and there are 152 participants registered. So from this text, I do know that the College of Liberal Arts has an auditorium, and that this auditorium fits at least 152 people. And if I keep reading the news, I will say that translation will be made available. So I do know that this auditorium can offer this possibility. So what I've been thinking of is that maybe we could develop a tiny system, focus on parsing semantically the news from the university website and the websites from each unit of this university, so as to answer the question. Like, I need an auditorium for more than 100 people that is suitable for translation. So that's an idea that I would like to develop, and I got really interested in reading previous ideas about that and papers on those ideas to get a grasp on how to make this question answer system possible.
Thanks. Okay, because we definitely have not had enough class participation yet, I'm actually going to ask people a couple of questions. So just to focus a little bit more, out of the first section, which of the two, not, as we said, not completely separable techniques, but which of those two techniques, heuristic or statistic, would you apply to Thiago's problem? So Thiago has an answer, but I'm going to
No, I'm going to say, great, we are already moving on my new project.
Okay.
Contributions, people.
Yeah, so Thiago, pass the mic.
Yes. I'm going
First
to choose one of my students because I can do that to them.
Yeah, you can do that. Go for it.
Então faça isso. Que em português. I think that maybe the ideal would be using the statistical technique, and I believe that maybe it would be an efficient way to find the answers that you need. And this way you are working with a more complex and direct information that represents the tools and equipments that you have available. I think it would be enough.
Okay. Now I have a follow-up question. What would be the biggest challenge for using a statistical system to answer Thiago's question? So I think it's definitely, in terms of, I think statistical system is a good answer for being able to get, you know, a lot of accurate information and being able to generalize in a nice way. So it's really good for that. But I'll sharpen the question slightly by asking, do you mean a statistical system for semantics, or do you mean a statistical system for the syntax?
Eu pensei para sintaxe.
Where do you get the corpus? Where is the syntactically annotated corpus to do your training?
No próprio site da universidade.
In college website, in all the sites that we have here inside the college, maybe we could find this corpus and make the correct annotations after that.
It's possible, but Thiago will have to make a separate grant for that. For the syntactic parsing part? Because you'll need a big corpus.
Yeah, I think that's, that would be my answer to your first question to Ludmila. I think that our biggest problem is probably, or we might end up with a training corpus that it's exactly the same size of the final amount of text we want to automatically parse.
Yep.
But of course, this would have a good impact in the sense that if we were to take every web page of every institute or faculty and annotate it and all the news produced so far, then we could have a system that would categorize further developments in the university.
Yep. It would still be worth doing for sure, but depending on how many web pages you have, I'm sure that if you take all the text that's in the university domain, clearly that's going to be enough to do syntactic parsing for Portuguese. But if you just take these news items, it might not be enough. I don't know how much it is. I'll tell you that the best systems train on at least 100,000 sentences. That's a lot of syntactic parsing. So that's why I say it would be, an independent project that you would want to independently ask for funding for first, to even produce for Portuguese a big enough corpus to do syntactic parsing. Because I have checked around a little bit, and there's not a big corpus that you could use, and there's not a real, neither for Portuguese nor for Spanish, is there a real statistical parser. Because the statistical parser requires a very large training corpus, which has never been funded.
Yes.
So I don't mean that to be too depressing. It might be possible to fund it, but it just hasn't happened yet. Okay.
Because my formation at computer science, again, we think in this case about a top-down approach to this type of problem. Maybe it's more easy as the domain is very specific, in this case only. Maybe it's more easy to think about the structure or the frames related to the situation and a priori establish some words or values in the frame context and look for in the web pages of the university for these frames and values and look for some relations as the frame element are already defined. I don't know if this type of approach is is classified as heuristic or another name.
So
this top-down approach.
Yeah, the top-down approach is usually associated with a heuristic approach. Some people distinguish between heuristic and artificial intelligence. So an artificial intelligence approach, which sounds very much like the top-down approach we're talking about here, is you take some structured knowledge that you have, right? For example, and you use this structured knowledge to figure out what kinds of information you can get. Then probably you're going to have a heuristic part where you either heuristically figure out the syntax or you heuristically figure out something even dumber, like a sort of information extraction, in order to fill the information from the frames. And if you already know which questions you're going to ask, this is definitely a smaller investment. So if Thiago only wants to know about auditoriums on campus and what they can do, I didn't think so. But if it was the case that that's all he wanted to know, then using a top-down approach would be obvious. But if he wants to know more questions, then it becomes less obvious because the heuristics that you have to introduce, it's not clear how many of them you will need. Now, it can be answered very functionally. You can, one of the things that's nice about a heuristic system is that each piece you add adds functionality. So you could first add heuristics for figuring out how many people go into an auditorium and what other capabilities it has, and then move on to other things. It's a very attractive thing that way, but if in the end what you want is a full question answering system, then it's not clear whether that's, you know, using a heuristic for everything under the sun is probably more work in the end for the complete job. So really, again, it comes down to engineering. If you know what you want already and what you want is limited, then actually there's a pretty good engineering choice. If you don't know what you might want in the future, it's pretty hard to use a heuristic method for the search part. You might see Thiago's proposal is that you probably want to use one of the already existing Portuguese heuristic parsers, chunk parsers, and then hook that up with probably a state-of-the-art, statistically based, automatic semantic role labeler. So that would be what I would consider to be the shortest path. But, you know, that might not require funding for a whole other project, so that might not be the answer that Thiago wanted.
No, in fact, what I wanted to add is that the idea is to be able to find every kind of teaching resources broadly understood as resources. Mm-hmm. So an auditorium would be a resource, a lab would be a resource, a multimedia projector, or even, say, a notebook mm-hmm. that you can borrow and take to class, or a video camera, or, I don't know, a speech recorder, this kind of stuff. Mm-hmm. So, because we do have entries for all of that. We have a huge system that controls every single piece of equipment inside all the buildings in this university. And they are linked to departments, and they are linked by their turn to units. So we have lots of databases. And if we could, in fact, teach the system that the word computer is a kind of resource, then it could locate, you know, computers in the list of computers for each department and this kind of stuff. Mm-hmm. And I do like the idea of not needing a whole new funding.
Okay, that's good. Okay, well, I think we should go ahead and leave it there for today. You actually have a good chunk of reading. And I will warn you in advance. I'm actually going to ask you what questions you had from the reading early in the class tomorrow. So please do read the reading, or at least be able to fake it. Okay? Thanks a lot, guys.